Okay, this is the third topic in this chapter, and they're all big topics, and there's really a lot in there. That's why we've got 2 weeks allocated to it. But this is on production bottlenecks. And what that is like a constraint in the process where the demand exceeds your ability to produce it. In other words, I've got a machine that can only do 40 units per hour, but maybe I could sell 50 units. So what you want to do is you want to sell the product with the highest contribution margin per unit of the constraint. Okay, that's the what you want to think through this whole thing. So the highest contribution margin per unit of the constraint. And frequently it's a machine, okay, that we're looking at. So the theory of constraints is a manufacturing strategy that focuses on reducing the influence of bottlenecks on production processes. So wherever you've got things backed up, you want to see if you can move those a little bit faster, okay? So when a company has a production bottleneck in its process, it should attempt to maximize profits subject to the production bottleneck. So in doing so, the unit contribution margin of each product per constraint is used. Okay, so what we're doing, this is the same thing right here. Just keep that in mind. You're looking at the highest contribution margin per unit of the constraint. Okay, so how's that going to work? Oops. Here's an example. We've got this Pridecraft tool company that makes 3 types of wrenches: small wrench, medium, and large. And all 3 products are processed through a heat treatment operation which hardens the steel. Okay, the heat treatment is operating at full capacity and is a production bottleneck. So what we've done here is they've calculated, here we've got our selling price, $130, $140, $160 for the large one. The variable cost is the same for each one, so the contribution margin is really different. On the small wrench, the contribution margin is $90, and the heat treatment hours per unit are 1 hour, okay? The medium wrench, contribution margin is $100, it's more, but it takes 4 hours to go through the bottleneck, okay? And then finally, the large wrench, the contribution margin here is $120, okay? That's like of a third greater than the smaller wrench, but the heat treatment hours are 8 hours. So what we're going to do is look at the contribution margin per unit of the constraint. So for each heat treatment hour, I've got a $90 contribution margin here for the small one, right? For the small one, let's put that in there. Okay, so this would be, the little one would be $90 per unit of the constraint. For this one, for the medium wrench, it's $100 in 4 hours. So that would be 100 divided by 4, or $25 per unit of the constraint, contribution margin. And finally, for the large wrench, it's the contribution margin is $120, and it's 8 hours. So that's $115 per unit of the constraint. That's all we're making. Okay. So if you look at the constraint, we can put a lot more small wrenches through than we can large wrenches. All right. All right, so what they're doing is looking at the contribution margin. This is what we just did, divided it by the heat treatment hours per unit. And we got 90, 25, and 15, just like we did. So that is the unit contribution margin per hour of the constraint, okay? So product A has a unit contribution margin of 15, 20, and product A requires, what's this one? Oh, this is another one, sorry. We've got 2 products, A and B. A has a contribution margin of 15, B is 20. A requires 3 furnace hours, while B requires 5. Okay, so which is the most profitable product, assuming that the furnace is the production bottleneck? So I would take my contribution margin of 15 and divide it by how many hours? Product A requires 3 furnace hours. So that gives us $5 per unit of constraint, okay? For B has a contribution margin of 20, okay, it's higher, but that also requires 5 furnace hours. So we get $4 per unit of constraint. Okay, so the most profitable product then, even though the contribution margin is lower, we can push more through the furnace or whatever it is, furnace. So that would be the most profitable product. Whoops, that's pretty big, huh? A little bit too big. Okay. And that's about it. So do some problems with this and you should be in good shape. Just remember the contribution margin per unit of the constraint. That's what you want to look at. Okay.